Alright, in this lesson we're looking at tan graphs, and let's have a look. The period of a tan graph is pi over n, so n is the coefficient of the x, and tan graphs form vertical asymptotes. And to find the vertical asymptote, we use this equation. So you do 2k plus 1 pi 2n plus or minus h over n. So h, so that's the translation, and that's the dilation factor from the y-axis. So that is, if it's minus, we minus. If it's plus, we plus. And with the x-intercept, we get when y equals to 0. So we basically solve using the trigonometric equations. All right, let's have a look at an example. So where k is element of an integer. Let's have a look at an example based on this. So we start with the vertical asymptote. So the vertical asymptote for this will be 2k plus 1 pi over 2n plus or minus h. So the h value is 0. We don't have any translation on the x-axis. So for that reason, so that will be 0. So we don't need to worry about that. So the n value is the coefficient of the x, which is 1 in this case. So 2k 1 plus 1 pi over 2n, where k is my in this case k will be 0, 1, 2. K is an integer. So if that is 0, so that my vertical asymptote must be a half, and the next one will be 3 pi over 2. So that's going to be 5 pi over 2. But because this is restricted domain, so we don't need to worry about the 5 pi over 2, because that's over 2 pi. So this is going to be the only thing we need to graph or to indicate. These are the vertical asymptotes we need to indicate on the graph. So the x-intercept we get when y equals to 0. So if I zero the y, so that gives me so tan inverse 0 is 0, and also pi and 2 pi. So my graph should look like something similar to this. So if I label my vertical asymptote, that's what I'm going to start with, which in this case is a half pi. And my other asymptote is 3 pi on 2. And my x-intercept is 2 pi and pi, which is somewhere there, and 0. So I need to indicate. So you finish along the asymptote. So this bit goes up and that bit goes along the other asymptote. So it's in between, my intercept is in between two asymptotes. So that's going to be my x-intercept, and the other x-intercept is this way here, which is along that side there. So make sure you indicate, so that's your vertical asymptote and the coordinates of the x-intercept. Alright, let's have a look at another example based on an tan graph. So this time we're going to have a translation. Alright, this time we can, again, we're just going to start with the vertical asymptote. Again, we don't have the value of h, so the value of h is 0 because there is no translation on the x-axis, and the n value is 1. So that means, and the k is an element of an integer, so k is an integer value. So in this case, because it's a restricted domain, if we start from -1, 0, and 1, and we say our x-intercept, so our vertical asymptote, I should say, if I substitute -1 in there, so that gives me -1/2 pi, and if I substitute 0, so that gives me pi on 2, so that's going to be 3 pi over 2. So those are the vertical asymptotes. The next thing I need to look at is the x-intercept, and we get the x-intercept on y equals to 0. So I zero my y, and I do transpose in order to find the x-intercept, or I can actually use the general solution, which I'm just going to show you in a minute. Just going to remind you in a minute. So 2n, so it's n pi, not 2n, n pi, tan inverse Alright, my x value should be n pi plus tan inverse negative square root 3 over 3. So we know that negative square root 3 on 3 is negative pi over 6, n, where n is an integer value. So in this case, 0, 1, negative 1, I should start from -1, starts from negative. So that means -1, 0, and 1. So sub it in, so that gives me -7 pi. And my next value should be -6 pi. And 5 pi over 6. So those are my x-intercepts. And the next thing I need to do is just sketch that. So now I have my vertical asymptote. For tan graph, you need your vertical asymptote and your x-intercept, so that's it. But this one here is actually, there's a translation of 3 units, it's 3 square root of 3 units up. So that means the endpoints. So we need to indicate the endpoints. So that means when x equals to negative and pi, so it's 0. So that whole lot is 0. So that gives me square root 3. And my other endpoint will be, so those are supposed to be indicated in any graph. So your endpoints need to be indicated if that's restricted domain. So in this case, it's a restricted domain. So we need to indicate our endpoints. And graph will look like so our vertical asymptote is negative pi on 2. So we also know that when x equals to 0, the whole graph has been shifted up. And we also know the other asymptote was pi, half pi. And when x equals to pi, so the endpoints, we need to indicate our endpoints. So this is x. So this section has to be so a graph will look like, so that's going to be square root 3, and at that point there, when x equals to negative pi, so it's going to be infinity. So that's my endpoint. So that's going to be negative pi square root 3, and because the graph has got a translation to square root 3 units up, so that means we also need to get the x-intercept, so the x and the y-intercepts. So our y-intercept is square root 3, and that section finishes along the asymptote. Just going to start from the asymptote, much easier. And you're not supposed to touch the asymptotes. So that's 0, square root 3. And we know that our x-intercept, we found that negative pi over 6. Negative 7 pi it's outside the domain given, so we're not going to include that. And our other x-intercept was, so let's actually indicate our endpoint, so which was along this side here. So that is, so that bit finishes that end. So that's going to be pi is square root 3, and this was 5 pi over 6, and the y is 0. All right, let's look at another example that has a vertical translation and horizontal translation. All right, we always start, so the given domain is So this is my given domain. Alright, so vertical asymptote again. So my h value in this case is pi over 2, n value is 1. So that means 2k, where k is an integer value. So that's how we get the x-intercept. So the vertical asymptote, I should say. So that means if I substitute 0 in there, so that gives me pi. So that equals to pi. And if I substitute 1 there, so that's going to be 3, 4, so that's going to be 2 pi. What? 2 pi. And that's why there. So that forms a vertical asymptote at 2 pi. So the next thing we need to do is to get the x-intercept. So we get when y equals to 0. So that means if I zero that, so that gives me tan so x plus pi over 2 equals to and x must be negative pi tan inverse negative a half. It's going to be plus actually. So if I take the negative out, so we also know that tan a half is the same as tan because they both undefined. So we're going to say pi, take the negative out, negative. So you're just sketching this, we're not using technology, so take free. So that means that's one with x-intercept. So because the domain is also, we know that tan 3 pi over 2 is also the same. So that means my other x-intercept must be 3 pi over 2 minus tan inverse a half. A half is not in the unit circle, so that means you have to indicate those on your x-intercepts. So let's sketch that. So again, we're just going to start with the vertical asymptotes. Our vertical asymptotes were 2 pi and pi. So that's 2 pi. And that's pi. And we had x-intercept has to be, so that means it's in between here, so it's going to go somewhere there. Oops. Just going to grab it again. It's always a good idea to start from the asymptote side. And we finish towards the x, towards the other asymptote. You start from one asymptote and you finish the other asymptote. So that's my rough sketch. So that means that's going to be pi over 2 minus tan inverse, so that's one of the x-intercepts, a half, y equals to 0. So along, so getting closer to the asymptote, that should be, let's get closer to that, so I'm just going to do it again. Getting closer to the asymptote. That's better. Not touching the asymptote, but getting closer to the asymptote. So that is 3 pi over 2 minus tan inverse a half. And this example has, and this one was 2 tan x plus half pi plus 1. That's what the equation was. It has a horizontal translation and a vertical translation. Alright, in our next lesson we'll look at cosine and tan and sine graphs.